Hello and welcome to another edition of Mrs. Cuentas Message Mondays. I have a few announcements for you guys today, and then I'm going to actually teach you guys about acids and bases. And that'll be wrapping up the last few topics that you have in your chemistry review and the scientific method topics. So we will be wrapping that up this week, and you guys will be moving on to a different topic. So woohoo, you're already done with the first topic. And then if you guys actually look back to your left in the back of the room, there's a list of topics that you guys will go through this year in biology, and so you're close to eliminating that first topic that we're going through, and then we'll be heading on to something different this week. So the few announcements. Just a reminder to you guys to take Edmodo assignments seriously. There were a lot of people who didn't turn in the Edmodo assignment. There were 3 chemistry review questions. There were a lot of people who didn't turn those in. So just because something is assigned on Edmodo doesn't mean that it's not important. So Edmodo assignments are graded, and those will go in the grade book. So make sure that you do whatever assignment that is assigned as homework. So if you have any questions on that, please talk to Mr. Eiding or email me or message me on Edmodo, or let me know if you have any questions about how to do that. But don't just ignore those things, because you're going to need homework credit. So if you haven't been taking those seriously, please start taking those seriously. Some of you haven't uploaded an Edmodo profile picture yet. If you guys could do that, that would be really great. I would like to be able to come back and just jump in and know what everybody's face and looks like, and have a name attached to that face. So if you could upload a picture of yourself, and I did see that some of you uploaded a picture of like an animal or an avatar or something like that. So if you could upload a picture of yourself so I know what you look like, that would be really helpful to me, so that when I come back we don't have to spend a lot of time, or I don't have to spend a lot of time trying to get to know you guys if I already have a name matched to a face. So if you guys could do that, that would be really helpful. And that was also an assignment as well. So really pay attention to that homework, even if it is on Edmodo, and please take it seriously. The schedule for this week, like I said, we're going to actually wrap up that first topic with the scientific method and the chemistry review, and then we're going to actually move on to our first kind of really actually biologically specific topic. So I'm really excited about that. So you guys are going to be doing that this week, which means that we'll need to test over the materials. We still haven't had a test this year quite yet, so you guys will take a test this week. Again, don't panic. A lot of my test questions come from bell ringers and previous quizzes. So if you have been keeping track of your bell ringers and your quizzes and your graded homework, you should be good to go. And if you pay attention during the biology basketball reviews, you should be fine. So the test will probably be Thursday, if all goes well. So please start studying for that. Study your bell ringers, study your graded quizzes, study anything that you got back, and study from the little bit of reading that you guys have had to do in your textbook. So that'll be Thursday. And then today I actually do want to teach you guys a little bit about acids and bases. So for those of you who it's really hard for you to take notes and to listen, don't worry about taking notes right now. You guys will have time after this video to take notes. So right now, just listen. And also, I can upload this video to the Edmodo folder, so if you don't catch something the first time or you don't understand it the first time, you can go back to the Edmodo folder and watch this video again. So don't worry about taking notes right now, just worry about listening, yeah, we'll go ahead and get started. So a lot of you have heard of pH scale and acids and bases. We're not going to get into too much detail about the chemistry of that and how that works, because this is a biology class, so we do a little bit of chemistry and then we jump into biology. So I'm not really so concerned that you know the details of the chemistry of the acids and bases, but you guys did do a little bit of reading about that. That was a reading assignment was assigned last week to read about acids and bases in your book. So if you have trouble with this, that's another resource that you guys can use to review. So acids and bases, you've heard of them before, you've probably studied them before, you have them in your house, you have them in your body. They make up a lot of solutions around us. So acids and bases, acids tend to be things that are sour, and bases tend to be bitter and slippery, and we'll get to what that means in a minute. And acids tend to be substances that, when dissolved in water, donate a hydrogen ion or a proton, and bases actually accept a hydrogen ion or a proton. So there are going to be a lot of chemistry things that you, again, I'm not necessarily expecting you guys to understand for this, but I'll get to the main points of why we want to learn this for biology. So the differences in intensity in acids and bases are actually measured on something called the pH scale. So the pH scale looks a little bit like this. So for the pH scale, we have a scale that goes from 0 to 14. And so the further you go towards 0, the more acidic something is. The further you go towards 14, the more basic something is. And then right around in the middle here, you actually have things that are neutral in terms of pH. So if we say that something has a pH of 2, it would be somewhere around here on the scale, and it would be acidic. And if we say that something has a pH of 10, then it would be somewhere up here on the scale, and it would be basic. Now the stronger you get towards 14, or the further you get towards 14, the more basic something becomes. The further you get towards 0, the more acidic something becomes. So if something has a pH of 1, it's a much stronger acid than something that has a pH of 3, even though they're both acids, if that makes sense. So examples of acids would be actually lemon juice and vinegar, and actually you have acid in your stomach, but we're going to get to that in a little bit. It's actually a really strong acid that you have in your stomach called hydrochloric acid. And then examples of bases, a lot of cleaning utensils and materials are actually basic. So things like bleach, toothpaste, soap, a lot of those things are very basic. Things that are neutral, things like pure water, your saliva is very close to being neutral, and the solution that's inside of cells, inside of most body cells, are actually pretty neutral on the pH scale. So that's kind of just a basic breakdown of the pH scale. So it goes 0 to 14. The middle number 7 is neutral. So if something has a pH of 7, that means that it's neutral. It's neither acid or base. But you go slightly in either direction, and you're starting to get something that's more acidic if it goes this way, or basic if it goes that way. Okay? So that's kind of how the basic scale works. This has actually come up last year and a couple of years before when I taught biology. Some students ask, like, what happens if you combine a really strong acid with a really strong base? Will they just fight it out? And a lot of people in their minds, they tend to think of acids as a really strong chemical, but actually really strong acids are quite dangerous, and really strong bases are also really quite dangerous. And when you put them together, they actually don't fight it out, they actually neutralize each other. So if you just dumped an acid or a base, which I'm not recommending that you do, because that's not safe to work with really dangerous chemicals, but if you just dump two together, they wouldn't duke it out, they would actually neutralize each other. So that's what happens there, and I'll give you an example of that in just a second. So you might be asking, that sounds like a lot of chemistry. Why should we care in biology about acids and bases? And it's actually very important for living things to maintain homeostasis. You've probably heard that word before, but homeostasis basically means to maintain an internal balance. So all living things need to maintain an internal balance in order to sustain their livelihood. And if homeostasis is thrown off, if your internal balance is thrown off, ultimately you can either suffer, get sick, or eventually, if it's bad enough, you can actually die if your homeostasis is thrown off. So one of the things that your body needs to maintain, and other living things needs to maintain, is a certain pH. There are some organisms that can live in really acidic environments. They're called extremophiles, and we'll actually study those organisms probably later on in the year. But some organisms can live in a really acidic environment and survive, and that's where they thrive. Other organisms can live in really basic environments, and it's really intense, and that's what they need to survive, and they're adapted to that, and so they survive. A lot of living things need a neutral environment to live in. For example, some fish need a neutral environment. If the pH is off just a little bit, those fish will die. And that you can see that when you have saltwater fish and you try to put them in freshwater or vice versa. So living organisms need a very specific pH, and actually different parts of your body need a very specific pH in order to operate correctly, and if that pH is thrown off, then you either get sick or something more tragic occurs. An example is, well, let's go back to the acid in your stomach. So yes, you have a very, very strong acid in your stomach called hydrochloric acid, and you might be saying, like, how does it not eat away at your body? Your stomach actually has a really thick mucus lining that serves as a buffer, so it doesn't, like, if that buffer weren't there, your stomach acid would actually destroy your stomach tissue and eat into the rest of your body. So the acid in your stomach is really, really strong. And if you've ever known anybody who has heartburn, that's actually a result of their stomach acid. So heartburn actually has absolutely nothing to do with your heart. Basically what heartburn is when some of that stomach acid starts creeping back up into someone's esophagus. And it's called heartburn because your esophagus is right in front of your heart, so it just seems like your heart is burning, but it's actually esophagus burn. So if anybody says they have heartburn, you can actually say, they actually mean esophagus burn. So what's happening is that hydrochloric acid out of your stomach is actually burning your esophagus. So people get heartburn, they tend to get heartburn when they eat certain types of food that have a lot of acid. So people who have this tendency, if they have really spicy food or really acidic food, the acid in their stomach gets worse, gets stronger, and so that acid starts creeping back up. And so what they actually can do, like what I was talking about earlier, if you add a base to something, it doesn't actually fight it out. It actually, if you combine an acid and a base, they kind of neutralize each other. So everybody's heard of Tums. Tums is actually, it's an antacid, means anti-acid. It fights against acid, but basically what it does is it's just a base. So Tums are made out of something that is basic. So it's got a pH near 14, and your stomach has a pH of near, like, I think it's 1. So what they do is when you take a Tums, what it basically does is it neutralizes the acid in your stomach and brings it further towards neutral. So that's why taking Tums works, is because you're actually eating a base, and then it simmers, it calms down the acid by neutralizing it and returning your stomach a little bit closer to neutral, but not completely. So that's heartburn. That's just an example of pH and why pH is important to living things to keep it in balance, and that's an example of the pH scale and how it works in terms of living things. So there are a lot of other examples that I could give you, but that one was one that I figured you'd all be familiar with. So we're not the only ones that need to maintain that, and that's not the only part of our body that we need to maintain a certain pH in order to maintain homeostasis or stay healthy. So us and all other living organisms need to maintain that regular pH. So that's the point that we want to drive home today with pH, is that living things need a certain pH in order to maintain homeostasis, and that's why we care about pH, and that's why we're studying about it in biology. So this is getting to be a little bit long video, so I'm going to sign out. I hope you all had a good time at Snowbird? What's the name of that? Whatever the name of the retreat was. I hope you guys had a good time, and I look forward to seeing you guys in a few weeks.